8 hours a day.
Lesson number 26, trinomial factoring and overlapping right triangles. When we are factoring, what we're actually doing is undoing multiplication. So when you are multiplying things, let's say we've got x plus 1 times x minus 2. When you multiply that, what do you call that when you multiply two binomials? FOIL. Because you're doing the first terms, and then you're doing the outside, then you're doing the inside, then you're doing the last terms. So FOIL. What factoring does is the opposite. It undoes your FOILing. A lot of times we'll call it in math, it's just kind of a catchword only in my classes, as we do anti-FOILing. You know, we do the opposite of. Okay, so if we were to do that and we were to FOIL that, we would get we would get that. So this is where we're starting. So we're not FOILing. We're going to start with that, and we're going to end up with that. So what we're actually doing is factoring or breaking down into a simplified part trinomials. So let's look at some rules as far as doing that. You guys have all done this. This is not new stuff, but it is good practice to continue to get as life goes on. Okay, so some different rules that take place with this. What we're looking for, whenever you have a trinomial that has as its exponent a 2 and has as its coefficient leading coefficient. You know what leading coefficient means? The first number in front of the x, which in this case is a 1. The first number that appears when it's in descending order according to exponents. Oops, I'm sorry. Let me get rid of this x. I don't know why I had an x up there. So the leading coefficient is 1. The exponent is 2. Once you have that established, then you can be like, okay, then maybe I can factor this. We will be doing some other problems where that number in front of the x squared is a number other than 1, negative 6. And that makes it a little trickier. I am going to show you a process in order to do it step by step that makes life a lot easier. It's not just a guessing game like I was taught. But anyway, let's start first of all with something simple where we have an x squared and we have a number, a leading coefficient of 1. How you end up doing that. The easiest part of this whole thing is to make 2 parentheses. And just a little segue or a little rabbit trail off of this. Every trinomial can be factored, but not every trinomial can be factored easily. There's 3 ways to factor a trinomial. Trinomial, tri means what? 3. Not because there's 3 ways, but because there's 3 terms. But there are also 3 ways of doing it. The first one is the easiest one that you always want to try first, and that's what we're doing today, factoring it into 2 binomials. The second way that we'll be doing later on is called completing the square. And then the third one is called using the quadratic formula. Have you guys heard the quadratic formula?
Yeah. 4 now.
Quadratic formula is you seen that?
Yes.
Okay. So if you can't factor it the simple way by doing simple factoring into 2 binomials, quadratic formula and completing the square always work. Takes a little more time to do it, but if you need to factor it, you can always use that method. But we want to try factoring into 2 binomials first, because again, it's the easiest. Okay. First thing you do is take the square root of the first term.
I got that.
You got that?
Oh, yeah.
You're ahead of the game, Ben.
And right now.
Then you find 2 numbers,
And
You find two numbers when added together give you -5, and multiplied give you +6. So two numbers. So what you're looking for is are factors of 6. That when you add them, you get a 5, and when you multiply them, obviously, if they're factors of 6, they'll give you a 6. So you have two choices there that actually work. Two numbers that add together give you 5 would be 2 and 3. And 2 times 3 is 6. You also have 6 and 1. 6 plus -1 is 5, and 6 times 1 is also 6. So you actually have two different numbers there that we're looking at, 6 and 1, and 3 and 2. Well, there are not two answers to this. So now what you got to look at is what is going to give you a +6 and a -5. Can you ever add a 3 and a 2 together to get, can you ever add a 3 and a 2 together to get a -5?
Yes.
Yeah, you
Negative
can.
3 and negative.
If this is negative and that's negative, you get -5. If you were to take those two numbers that are negative, -3 and -2, and multiply them together, are you going to get a +6?
Yes.
Yes. Okay, so that works, Ben. 6 and 1. Is there any way that you can add 6 and 1 together to get -5?
Negative 6.
-6 plus 1 gives you -5. If you multiply those together, you get -6. No, you
You
get,
get negative.
or you do get -6. You need a +6, so they don't work. So when you're doing this, guys, really, really, really pay attention to the negatives and positives, because that's either going to make the problem right or wrong. So what we've got here is x -3 and x -2.
And that's the answer.
And that
You've got nails.
that is what that is equaling, or what we just did is we just simplified it. We didn't find an answer. We didn't find an x. Yeah, there's no equal sign, you don't find the x. Only if there's an equal sign. Now, if I put, this is just kind of free here, if I put it equals 0,
You have to do 4 over.
what you can do is find out what number will make this parenthesis 0. 3 minus 3 makes that 0, right? So if x is 3, this whole thing will become 0. 0 times anything is 0.
But wait a second, what if?
also be
Oh,
Yeah, that's what.
X could also be 2. And there's some interesting information that you get from that.
Right, we're
That
trying
is
to make it
called,
0.
those are called the roots of the equation. And what that number is where the graph crosses the x-axis. It crosses the x-axis at 2 places. Actually, what the graph of that looks like is something along that line. So it crosses the x-axis in 2 places. Those are the roots of the equation. But we'll get into that later.
Why do we make
Probably
it
next
equal to
year.
0?
Hmm?
Why is it equal to 0?
I just decided it was equal to 0 because I was looking for
We don't
those.
need that on it.
You don't need any of that. No, that was just free stuff. You didn't even have to pay for it.
You know,
Actually,
It's like
it,
that bin.
we just got
Yeah, it's like that box at a garage sale that says free on it.
and most of it's worthless.
Most of it's worthless.
Like,
So maybe that was
okay.
worth it.
Use whatever wash.
That's what I was going towards.
You do this 6 hours.
But it's not like it's
Okay. Okay, so this equation up, or this expression up here, what is wrong with that?
It's negative.
There's a negative. What did I say had to be the leading coefficient?
Positive.
Positive 1.
So now you just make
Okay? I have a negative there, so I can't have a negative.
it positive and everything else negative.
Okay, so what we're going to do, we're going to do what Elias said, but I'm going to at least explain the theory of it before we just do it. Okay. What we're going to do is we're going to remember how yesterday we took that and we factored out what was common to each term.
Yeah.
Okay? We're going to do the same thing. We're going to look at this expression up here, and we are going to take a negative out of each term and take it out here.
I think you got the 5 and the 14 mixed right. Possibly.
So now, if we can multiply this negative by this and get a negative x squared, this by a negative and get a positive, and this times this and get a positive, we're good to go. It works, so we can do that. So now what I'm going to do is I'm just going to drag that negative sign each step of the way, not do anything with it except just let it sit there and just worry about what's in the parentheses. So at this point I've got my negative, I'm going to make 2 parentheses, square root of my first term, find 2 numbers, multiplied, give me negative 14, added,
What was that, Ben?
give me a negative 5.
Somebody said negative 7.
So, we've got a 7 and a 2. 7 and a 2 gives me 14. 7 minus 2 gives me a 5. Now I just have to play around with my negatives.
You got the 5 and the 14 mixed right.
No, you didn't.
It doesn't work that way.
Yeah, it does. It's 26.2.
The one on the right side has to be.
Look. Negative x squared plus 5 plus 14.
Okay, so what 2 numbers multiplied together are going to give me negative 14?
Negative 7 is
They have to be added.
Negative 7 and positive 2, but also 7 and negative 2 multiplied to give me negative 14.
Yeah, but it's
So
going to be the bottom one. You can't get
why is it going to be the bottom one, Elias?
You can't get negative 5 out of the top one. Well said, well said.
Okay, so if I have a negative 7 plus 2, I get negative 5. If I had 7 and negative 2, I'd get a positive 5. So I'd still get a 5, I just get the wrong sign.
And now we change everything back.
Okay, so I'm going kind of fast because you guys have had this.
Ben seems to be getting it.
Leave Ben alone. He's had a rough
Middle
couple
one has
days.
to be multiplied. The one on the right
Yeah, what
side
he
is
said.
added.
Yes.
John Saxon Day is on PSAT. Yeah.
John Saxon Day is on what?
PSAT Day.
What a better day.
You're right.
Multiplied is 6.
Okay,
So then,
Okay, as long as you like it.
so at this point, I'm happy.
But they haven't.
If
decided
you
what
want to expand it, if you want to multiply everything by -1 and change the signs, feel free to. I prefer personally what's up there now. But sometimes what people will do is they'll say, oh, I'm going to multiply that here and get that for my answer. I don't care, but I kind of like the one above it
you should do the
myself
FOIL
first.
method on that too. You get
Do the FOIL method on this?
I just did it and I got it right.
Okay, so we've got my first, my outside, my inside, and my last. So negative x squared plus 5x plus 14.
on the first one, like these multiply together with the middle term. So why is it the other way around this time?
Multiply together to give me the
That's
first
not a
term.
rule. You just made that up. It's not a rule.
I'm not,
On this, he said the numbers, these had to equal the middle term. And then added they made that one on the outside, they're opposite. That's what he said. Is there a rule for it? Does it have to be the middle?
we had, what did we have for that first one? X squared,
Plus 6x minus 5. Then we use -3 and -2 to make 6.
And multiplied there.
Let me pause here.
Discrepancy.
You already made that joke in the video. I didn't say action.
Okay.
You don't know.
So let's look at
I remember.
24 plus 6x minus 3x squared. First thing you're going to do with that is what?
Rewrite it.
Rewrite it. Okay, rewrite it for me, Seth.
Negative 3x squared plus 6x plus 20.
Okay, anybody see any problem that's going to make this a little bit difficult?
Well, what negative 3?
I don't like that -3. fact, I don't even know what to do with the negative 3. So what can I do?
What did they do to you?
What's that?
What
What'd you say, Ben?
Divide it.
I'm going to factor or divide out what is common to all 3 terms. Always do that first. Remember the last one was a negative x squared. We factored out the negative. Always the first thing you're going to do. See if you can factor things first and then go from there. Why did my signs change?
Dividing it by something negative?
I divided it by negative. Whenever you divide something by a negative, the signs change. Okay, so I pulled out a negative 3. So that means when I multiply back across, I'm going to get negative 3x squared. A negative times a negative is a positive. Negative times a negative is a positive 24 there. Okay, so now I've got my 2 binomials. Negative 3, square root of my first term. 2 numbers, multiplied giving me 8, added give me negative 2. So if you think about it, 8 and 1 is out of the picture because you can't get 2 with 8 and 1. All you can get is 7 or 9, depending on if you subtract or add. All right, the other options are just 4 and 2. So what numbers?
Negative 4 and 2.
Okay, we've got a positive 4, a negative 2, a negative 4, and a positive 2 that will give me a negative 8, but I have to get a negative 2x. That means my largest number has to be negative. So that needs to be a clue, is whatever sign is on your middle term, the one that works is that has the largest factor with the same sign.
It's hard to word it.
Right. So this is the one I choose because the
See what you're
largest
saying.
number has the same sign as that. So, minus 4 plus 2. Guys, please. So negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. And you leave it just like that.
Yeah.
All right, one more. I'll let you do this one on your own.
Yes.
$32x squared plus 12x cubed minus 2x to the 4th power. What is the first thing that you do on these every single time? Factor. Yes, thank you. I guess that's first. Put them in the right order, then factor.
Okay. What's it mean? She said son of God. Oh, designed by God. I thought she said son of God, and that's like DBG. Interesting.
Okay, let's go through this. We're going to do what Kelsey said first of all, put everything in the correct order. Okay, and then factor. What did you guys end up factoring out of this?
Negative
2x
2
squared.
Negative 2x squared, leaving me with
X squared plus 6. Minus. X plus 16. Finish line.
and then you factored that down into 2 binomials. Square root. What did you come up with?
Plus 2 minus 8.
Okay, you got an 8 and a 2. You know that somehow 8 and 2 combined, you'll get a 6 there if you take the difference. So I'm just going to put an 8 and a 2 in there. And how do you determine which one's negative?
It's a negative 6.
The bigger number has to be negative because that one's negative.
Don't forget the 2 squared on the other side.
Thank you.
Negative 2 squared. Oh, dang, you got it.
Okay, so there's where you stop. All right, overlapping triangles, 26B on page 122. Golly. These are overlapping right triangles then,
Oh, okay.
which means
It's the exact
we
same thing.
reintroduce Pythagorean. Because they're right triangles, we can use Pythagorean to find the side that we're missing. So, for instance,
Pythagorean.
if we have a triangle that looks like that and has a line right there, and I say this is A and that's B and this is C and that's 4,
The middle line.
this is 6
C4.
and that's 4. And what they're asking you to do is find A, B, and C.
Oh, that's.
Except these are right triangles, so it's a little bit different.
What's the difference?
So what I would suggest doing is make 2 triangles. So let's make the second, or the inside triangle, the smaller triangle, its own. And then this ends up being 4 plus 6. This is B plus A. And we can get rid of that there and just deal with comparing those 2 triangles. So how would we, which one would we find first?
Small one.
C.
The one with B.
Why C?
Because you can do 6 to 10 equals 4 to 6.
Yeah, you can combine those. There's only one variable in those little hatch marks there. So you can go C is to 4 as 10 is to 6, and you can do your cross multiplying and find out what C is.
Why would you do
When you
so?
do 10 and then 6.
What did I do?
C is to 10.
Oh, I did C is to 4.
Oh, that.
Is
Oh,
10.
I see.
Yeah, you can do it that way. You can do it, how did you say? C is to what? 10 as 4 is to 6. Either way, you're going to get the same answer, 40 divided
I
by
thought you were
6.
just doing C and then half of that.
Is it just as long
Half
as
of
you
the
have
4
the
plus
same
6.
Oh.
That's like,
angles?
What, Elias?
Just as long as you have the same 2 angles, it's pretty much
You
gonna
have
be
to
the
solve
same.
for a variable. So
Yeah.
that is 6 on both sides.
Okay, so at this time you find out that
Variable.
C is 20 over 3. So C is 20 over 3. All right, so let's change this here to a 10, just so that we're not bothered by that. And let's make this look a little nicer. B plus A. All right.
so confusing.
Now what are you going to find? A?
Hey.
So you're going to take what?
4 squared plus 6 squared equals.
Wait a minute. Say that
Over
again?
10.
4. You can use Pythagorean to find that. Whereas the other triangles, you couldn't use Pythagorean. You had to keep going with the proportions. Whereas this way, because they're right triangles, we can do Pythagorean. So we have 16 plus 36. What is 16 plus 36? Is there
No.
anything we can do with 52?
No.
2 squared.
You can make
52,
it
I mean, what are the factors?
You can make it 2 outside, 13 inside. 26.
They're
Or you
turning
just leave
into,
it.
or we can just leave it the way it is.
You can't do it.
Is that what you said?
Yeah.
So you're saying that 4 times 13 is 52? Okay.
You're like, I don't know if that's what I'm saying now.
Yeah.
That's right.
Okay, so 2 times the square root of 13 is your hypotenuse for the small one. Now you've got 2 times the square root of 13 plus b to give you the length of this hypotenuse.
Can you just do Pythagorean? Oh, that'd be really.
Yeah, you could do Pythagorean to find that other one. 20 over 3 squared plus 10 squared equals c squared, or that length
Wait,
squared.
what would be the other way to find that?
You could use proportions.
So like 10 over, or 6 over 10.
You could use 6 over 10 as a, 2 times the square root of 13 over q plus a. Yeah.
How would
Do either one. And b ends up being 4 times the square root of 13 over 3.
Wait, you said a over 6 plus b plus a over 10 or something
A.
like that?
Yeah, what I would do, I would just call this something else. I'd call it d or something, so you don't have b plus a. That's kind of silly.
Right.
So,
So how do you end up?
But then you can't really solve that.
well, you've got whatever a is,
Oh,
2 square root of 13 over 6 equals d over.
No, but doesn't it just
10.
equal the same thing? No.
Never mind.
So then you get,
So, but then you still have to subtract 2 square root of 13 from d, don't you?
no.
Because you're trying to find b, not d.
Oh yeah, once you get your answer, then you're gonna have to subtract. Yeah.
These are fun problems right
So there's
here.
like 43,000 different ways to do this.
10 steps.
Yeah. Well, it beats, yeah, the steps that calculus.
How do you divide that by 10?
How is it 20 squared of 13? Oh, I see.
Yeah. How do you divide 20 square root of 13?
So then I've got this divided by 6.
Which equals
10 square root of 13 over
3.
3. And that's what? That's this whole thing. So
I think it's easier just to use b.
it probably is.
90% of the time that circle thing doesn't work.
I know.
Especially
So
with yours.
10 square root of 13 over 3 minus 2 square root of 13 equals b. So now you have to find common denominators and all that stuff. So your common denominator here would be 3 and then change to a 6. So 10 minus 6 is 4.
have to do all this too.
Yeah.
And that's your answer for B. So
Okay, I
Wait.
wait.
Yeah, serious.
I probably didn't do it well, I did it normally the way I do it. I take kind of the hard route to do it. Plus I have a mess there going all over the place.
That is so
These poor people are
I
gonna
got to
Okay.
minus and then got the common denominator and then I quit.
Action.
Okay, D, practice, page 123, problem set 26. We have that triangle I split up. So this one is A, and this one is A plus B. This one is C. This one is 4, 5, and 8. Okay, so you see where all those came from? Okay. First thing we're going to do is find A. A squared equals 4 squared plus 5 squared. So A squared equals what? 4 squared plus 5 squared? Yeah?
41.
Thank you.
Good job.
So A equals what? Is 41 a prime number, or can that be reduced? Prime. So A is 41. Okay, can I erase that?
No.
Okay.
Oh, I forgot.
So A, well, let's just erase A up here and just put square root of 41 there.
Don't even ask me.
All right.
What if you get out with the triangles?
Whoa, let's find out.
That's a question.
You want to find out C next?
A square root.
Yeah, I know.
A squared.
So let's look at our proportions. C is to 4 as
8 to 5.
8 is to 5. Cross multiply.
C equals 40. C equals 8.
C equals 32 over 5. Can that reduce?
Hey.
No. So we're going to put a 32 over 5 here. Call that good? All right. We're also going to replace this A over here on this big one with the square root of 41. Okay. So now what do you want to do?
Start over.
Start over. Put it away and go to bed. Forget it.
Yeah. Okay, good plan.
Okay, you got a couple options here. You can do proportions. We could write b plus the square root of 41 over square root of 41 plus b over square root of 41. Okay, hypotenuse to hypotenuse equals
8 over 5.
8 over 5. And cross multiply.
Wait, would the 41s cancel?
Good question. Madison is asking if my 41s will cancel.
No, because there's a plus B. Because it's
Okay.
square root of 41 plus
That
B.
plus locks it to everything else.
Could you factor it out?
You could factor it out, but what you'd have is you'd factor the 41 out and you'd be left with a
1
1
plus
plus b over the square root of 41.
Complicated.
But that cancels when
You
you
can't
factor
cancel
it
that
out.
because of the plus sign with the 1.
No, but I mean, when you factor out, like, okay, so you would
You
factor
just have
out.
1 over
Madison,
B.
I want to get out of here.
All right, let's cross multiply. 5 times the square root of 41 plus b equals 8 square root of 41. Distribute. Now what?
Subtract the 5 thing.
3 squared.
Okay, you subtract them. Subtract.
Okay, now what?
Yes.
Now you're down the wire.
Divide by 5.
And you're done.
Woohoo! Yes! That
Could
wasn't
not have been
too
more
bad.
confusing.
Kendra, give me your notes. because-
Yeah, that was a little bit easier when I just did it in an orderly, systematic manner
See,
than
the way I'm
all
doing
over the
this, I have like
Yeah, that's what I'm
1/8.
doing on my
Is it
problem.
over here?
place. Yeah, what?
I have like 1/8 of the map.
How did you do it?
Oh.
Like the same.